Going to talk about prokaryotic replication. There are actually two different types of prokaryotic replication: theta replication and rolling circle replication. Theta replication is bidirectional, meaning it proceeds from two directions from the origin of replication. You can tell that this is the origin of replication because on either side there is a leading strand and a lagging strand. You can tell it's the lagging strand because you can observe the Okazaki fragments. Okazaki fragments occur because DNA must be copied at the 3' end. I have labeled this Okazaki fragment here 5' to 3' so that you can tell that the DNA it is copying must be antiparallel and 5' to 3' in the opposite direction, or 3' to 5'. Theta replication results in two circular molecules, whereas rolling circle replication results in many circular molecules. So let's take a look at how it does that. The replication fork continues around the circle many times, producing many strands when they are cleaved here. These strands are then used as templates to synthesize many more circular DNA molecules. Here's a close-up of what's actually happening at the replication fork in prokaryotic replication. This yellow magnet represents the origin of replication, and you can see that the replication bubble opens up around it. Helicase, the green magnet, is what attaches at the replication fork to move the fork and bubble outwards by breaking hydrogen bonds as the replication fork moves along the DNA. Primase is needed to make RNA primers for the DNA polymerase III to add bases to. This combination of primase and helicase is called a primosome. These purple magnets upstream of the replication fork represent gyrase, which serves to relieve the torsional strain from the replication bubble on the helical DNA ahead to keep it from supercoiling. All these little nicks along the replication bubble are single-stranded binding proteins. Now let's take an even closer look at what's actually happening. For reference, this is a close-up of this half of the replication fork, and here is where the primosome and gyrase are in this new diagram. DNA primase puts down a primer right here for this DNA polymerase III to add to. Then DNA polymerase I comes along to remove the primer. But as you can see, there's a little nick left missing, so DNA ligase comes along to seal that nick by forming a phosphodiester bond. And that is the summary of prokaryotic replication.